Hello, in this video we see complete basic Python in 1 hour. Okay, complete basic Python in 1 hour. Let's start. What is Python? Python is high level interpreted and general programming languages. It is designed to be easy to read and write with clear and concise syntax and emphasizes code readability and allows developer to express concepts in few lines of code that might be possible in language like C+ or Java. Okay, these are the key features of Python's here: readability, versatility, language. Okay, large standard library. You can check in theory here, theory part here. These are frameworks. Frameworks are designed based on the Python modules and libraries, including Django, Flask for web development, NumPy for the Python 3D and 2D arrays. Okay, Pandas for analysis. Okay, these are the theory part here. Okay, what is the use of Python? Why we use Python? Python used in various domains like web development, data science and analytics, machine learning and artificial intelligence, scientific computing, automation and scripting, game development. Okay, these are things. Okay, but mainly Python was extensively used in the data science and analytics, machine learning and scientific computing. Okay, when compared to other languages, if you take Java and other C++, whatever, web development, game development, so Java is bit advantage compared to the Python. Okay, but when come to the data science and analytics and machine learning and artificial and scientific computing, Python big advantage. Okay, when compared to the Java. Okay, so if you want to start your career using machine learning and artificial intelligence or analytics or data science, it's better to learn Python. Okay, in Python, but Python is also used in the web development, game development also, but slightly edge. Java has slightly edge. Okay, compared to Python. Even this language, cyber securities, education, databases, robotics. Okay, cloud computing. Okay, so these are the various domains where Python was used. Python is also extensively used in web development too. Okay, and next thing is why Python is strong in dynamic type languages. If you look into this chart, see strong, dynamic, weak, static. Okay, Python was a strong and dynamic. If you look other languages too, Java is a strong and static. Okay, and JavaScript is a weak and dynamic, and C++ static and weak. Okay, so look at this, various languages, and they're strong or dynamic or weak or static. You can see this language, you can see chart, and why Python is strong and dynamic languages. Okay, why Python was strong and dynamic languages, we will see with an example. Okay, and here theory part: Python is considered strong and dynamically typed because of its strict enforcements of data types and ability to dynamically determine the type of variable during runtime. So we'll see with example why Python is a strong and dynamic type languages. Why Python is dynamic type languages means just take one variable here, x. Okay, x equal to, and assign some value here, 5. Okay, x equal to, assign unsigned value, and print statement, print the value to the terminal here, x here. Okay, simple. Okay, just execute it. So we got 5 here. Okay, but you did not assign any data type to this x variable. Data type to the x variable. But if you want to know which data type, this value means you have to use type function, type of x. Just check it, which type it is. See, integer. Okay, that means Python interpreter automatically assigns this variable to the integer. Okay, this variable to the integer. You no need to write int x. Okay, like int x or string x, float x. Okay, float x, like this one. You don't need to write here like this. Python interpreter automatically detects the data type. Okay, whereas in Java you have to write it. Okay, in Java is a static language. In static languages you have to write integers data types. Okay, but in Python is a dynamic type language. You no need to write the data types here. Python interpreter automatically detects. If you see other example also, x is equal to, if you write here some Python string. Okay, and observe here, print. If you want to know which type it is, just check here, type function, we have to use that, and see string here. Okay, it's changed to string. The variable has changed to string here, same variable here, but the data has changed dynamically from integer to string here, because here first we have SN5 and Python. Okay, it shows Python is a dynamically typed languages. Okay, that's the reason Python is a dynamic type language. If you want to other type, data type, if just equal to true, so check which data type it is, print type of x. Just check the output now. See, z is equal to true, string type. Okay, actually it's a boolean type, type of z here. Okay, type of z here. Okay, just execute now. See, boolean type here. Okay, integer string, because true or false are boolean type. Python is a string type, is an integer type. You did not assign any data type here. Okay, Python interpreter automatically detects it. It changes to integer to string here. Observe here. Okay, so that's the reason Python is called as dynamically typed languages. And one thing, why Python called as strongly typed languages? Okay, why Python called as strongly typed language? So because just example, watch here. Just x equal to 5. Take another variable y is equal to 10 here. Okay, strings you have to write strings are carrying single quotes or double quotes. Okay, and just result is equal to add those two variables here, x plus y, x plus y, then print it. Okay, print statement, simple. Check the output now here. So it results error here. Okay, see, observe here, it got error because x is equal to 5 and y, x is an integer, y is a string here, because Python detects automatically. If you write in single quotes, Python detects it as a string here. Okay, because integer string cannot add in the Python, because Python is a strongly typed languages. Type safety is more in Python. Okay, so but in JavaScript is JavaScript it convert into the integer and performs additions, but in Python it's a strongly typed languages. It won't perform addition here. Okay, if you want to perform addition, you have to convert this into integer. 10. How you convert this integer? Just int function. Using int function, it convert into integer here. Simple. Integer. Okay, just check the output now. 15. Okay, so that's the reason Python is a strongly typed languages, right? And okay, these are because Python, these are the examples. You can check it here. Theory part, strictly typed, strongly typed, and type safety. And next thing is, what are the various data types in Python? These are the various data types: numeric data types, dictionary data types, boolean data types, set data type, sequence data type. Numeric data type, here description is there. Integer, okay, concept of integer numbers 42 minus 10 0, and float default concept of decimals 3.14. Float data type. Complex data type is like this: 2 plus 3j is a complex data type. String data type, hello. Okay, strings are should written in single quotes or double quotes. Okay, boolean type is true or false. List you have to write list in this square bracket. Okay, this square basis. Okay, 1 comma 2 comma 3 square basis. A tuple in normal parenthesis. Set in flower braces, and dictionary in the key value pair. Dictionary database key value pair, name John. Okay, this we'll see with an example. Just remember, okay, integer data types, float data types. Okay, and what are the input and output statements in Python? These are the output statements. First we'll see what are the output statements means actually the data given to a computer is called input. Okay, and the results are returned by the computer called output. Okay, to provide to input to a computer, Python provides some statements which are called input statements. Similar to display the output, there are output statements. Okay, to display the output, print statement. First of all, we will see first example, this print string here. What is a print string? Print function. To display the output, simple words, to display the output, you will use print statement here. It takes string form. Okay, see, suppose hello Python, print statement. Okay, observe here, just check the output, simple. And one thing you have to observe here, print statement, whenever you are written print statement, the cursor move to the next line. Okay, whenever you are written print statement, the cursor move to the next line. Suppose check here, like Python, just print hi, hello, whatever. Okay, so check the output now. See, the cursor move to the next line here, print statement. Okay, whenever you type print statement, the cursor move to the next line. If you don't want to move the cursor next line, means hello Python, hi Python, I want to display in the same line, so you have to use another parameter here, comma end parameter. Okay, end parameter you have to use if you don't want to move the cursor to the next line. Just use simple, okay, space. That's it. Just execute now. See, hello Python, hi hello. Okay, the cursor did not move the next line. That's a print statement, first one. Just and next, print variable list here. Okay, print variable list here, print a comma b. Suppose take some a is equal to 2, or a comma, you can assign variables like this: a comma b is equal to 2 comma 3. Okay, a is assigned to 2, b is assigned to 3, and print simple, print a comma b. Check the output now. 2 comma 3. Okay, 2 3. Okay, here 2 3, comma you won't display here because comma is, you have to write in, if you want to comma you have to write like this. Okay, comma single quote. Okay, because it takes as a string format, comma Just now check the output now. See 2 comma 3. Okay, this variable list you need to write in single quote, whereas string you have to write in single quote. Okay, print statement. Next thing is string and variable list. Third one, string comma variable list here. So simple, suppose a is equal to 2, print a comma is even number is even number here. Okay, just check the output now. See 2 is even number, right? The simple one. And next thing is there's various formats are there, input output statements. These are output statements, and these are this print formatted string. Okay, formatted string. What is a formatted string? We'll see with an example. And percentage variable list you have to write in parenthesis. Okay, formatted string. What is formatted string? Means print some whatever. Okay, take some a is equal to 10 or x is equal to 10, x is equal to 10, y is equal to 20. Okay, I want to display in formatted string format. Okay, print x is equal to percentage you have to write it percentage d. Okay, percentage d, percentage, and also variable list you have to write in x here. Okay, x in parentheses. Okay, so observe here. Okay, syntax, you have to remember the syntax here. Formatted string, percentile, variable list here. Variable list you have to write in parentheses. Okay, so check the output now. Simple, x is equal to 10. If you want to display these two variables, means x is equal to percentage d comma y is equal to percentile d and percentile x comma y. Okay, just check the output now. See, x is equal to 20, y is equal to 20. Okay, if you want to print string, this is an integer. Suppose if you want to print string, means z is equal to python, z is equal to python in formatted string format. Okay, for that you have to write it x for that you have to write z is equal to percentage s. Okay, percentage s here, percentage s, percentage z. Okay, see, python. And if you want floating format, you have to use percentage f here, float format. Okay, float format x. See, z is equal to 10.000 is there. Okay, but I want only two decimals, not complete decimals. For that you have to use 0 after percentile 0.2f. Right, see, two decimals here. Okay, so this is a formatted string. Okay, float, string, and integer. So if so various are there. This is a formatted string. Another formatted type is there. So another is replacement field. Okay, format string with replacement field dot format values. This is a syntax here. Replacement field is denoted by flower brackets here. Okay, we can mention in flower brackets, we can mention name or indexes in the replacements. It represents the order of the values. Okay, so we'll see with an example that one also. Replacement field, just take two variables here. N1 is n1 n2 n2 n3 n3 is equal to 1 comma 2 comma, take some python. Okay, example python, simple, n1 comma, right? So n1 is 1, n2 is 2, n3 is 3 here. Okay, so we have this formatted string replacement field. Print here number 1 is equal to, okay, number 1 is equal to 0, index 0 here. Okay, number 1 is equal to 0 comma number 2 is equal to 1 dot format n1 comma n2, simple. Okay, dot format n1 comma n2. See, number 1 is equal to 1, number 2 is equal to 3. So it is a sequence. Okay, if you replace with here like this 1 comma 2 here, suppose 1 comma 0 here, 1 comma 0, just check the output now. See, number 1 is equal to 2, number 2 is equal to 1 here. Observe here. Okay, so this is a sequence. This is a formats are sequence. Okay, we can mention names or index in the replacement field. It represents the order of the values. Okay, replacement field is denoted by flower brackets. Okay, this is an example of the string with replacement field. So I already give some, I already this one. Just check the output here. And next thing is this, you can do this one also, like this also. Print, you can write a replacement field in print statement also. Print statement, okay, like this one. So take name is equal some variable name is equal to Python print formatted string. Okay, formatted string hello name, variable name you can write here, variable name. Okay, simple. Just check the output now. Hello Python here. Okay, so this was introduced in 3.6. okay, this formatted string introduced by 3.6 provides a concise way to embed expressions inside string literals. Okay, so these are the some output statements, and see input statements here. Input statement nothing but if you want to enter input from the keyboard, from the terminal, if you want to enter input from the terminal, you have to use this input statement. First input statement is string is equal to input. Okay, this is a input function. Okay, it takes an object. Input takes string format. Okay, observe input takes an string format, not integer. Enter string here and print string. Check the output now. Enter string here, enter some string here, Python, whatever, Python here. Okay, so what Python takes input function takes a string here. Okay, input function takes a string, but if you want to enter number from the keyboard, you have to convert this string into integer. How you convert? Using int function. Okay, so just enter some number here, enter string here 112. okay, 12 number. Okay, so that's the reason. If you want to, suppose if you want to enter float number wise, you have to convert this into float here. Okay, so like that. And also if you want to, okay, if you want to enter two numbers at a time, if you want to enter two numbers, single line, two numbers you want to enter at a time at a single line, just use this. Okay, x comma y, enter two numbers. Okay, dot split here. So this we will use this, print x comma y, simple one. Just these things in this for loop. Okay, for x in input enter two numbers. Okay, this integer you will see later. Okay, but just remember, if you want to enter input same line, you have to use this one. Okay, enter numbers 1 space 2. Okay, 1 comma 2. Okay, space 2. And also one next thing is eval function. Okay, suppose you are entering some x is equal to, okay, int input this expression. Okay, enter this expression. Now suppose input 2 plus 3, enter expression. So you enter some expression here. So enter expression. Okay, some expression here 2 plus 3 here. Okay, suppose. So it gives output here. So it is, just check the output here. So enter expression, x is equal to enter expression. It gives some error here. Okay, suppose if you take out this integer also, just observe here, enter expression 2 plus 3. Okay, print x. Enter expression 2 plus 3 is given, but I want to perform addition here. So if you want to perform addition here, you have to use here eval function. Okay, eval function, evaluate function here, eval function evaluate the given source into context of globals and locals. It evaluate means it adds the function expressions here. Okay, just check the output here, enter expression 2 plus 3, see 5 here. Okay, so eval function is very important because eval function takes strings and evaluates the result of the string by taking it as expression. We can use combination of eval and input function to accept objects like list or tuples. When the user types using square braces, eval will understand that is a list here. Okay, because if you use eval function, if you enter list here, okay, print, so now you print type of x here. Okay, suppose if you enter list format here. Okay, suppose if you enter list format here 1 comma 2 comma 3, okay, list type. Okay, if you enter list dot type here, See, it's a list type here. Okay, if you write eval, if you don't write eval here, suppose if you did not return eval, it gives error. Just check the output now. 1 comma 2 comma 3 1 comma, but string format, so not, it doesn't give error, but it takes in string format here. Okay, but I want in list format. If you want to enter in list format, you have to write here eval. Eval automatically detects. If you write in list format, it detects as eval detects list, and if you write as an tuple format, it detects as tuple. Okay, so there's a different issue, but eval is important one. Just remember, evaluate function evaluates expression and also data types. What are the operators in Python? Okay, so in Python, operators are used to perform some computation between different variables. Okay, so there are different operators are there. You can see here: Python operators, assignment operators, arithmetic operators, comparison operator, logical operators, identity, membership, bitwise operators. Okay, we'll see what are these operators. First one is arithmetic operators. Arithmetic operators means to perform some computation between two operands. See here, this x and y are operands, plus or operator here. Okay, arithmetic operator, plus, minus, multiplication, division. Okay, square root, part, remainder. These are truncate. Okay, float, division. To perform these x and y are operands, to perform some arithmetic operators between two operands. Okay, these operators are used. So we'll see with example. So you know, float, division or truncate. Okay, division or float division, the difference will be there. We'll see with an example. Suppose x is equal to 8 by 3. What's the result here? We get it. X is equal to 8 by 3 in decimal form. Okay, so 2.666. But I don't want 2.66. I want whole number. Okay, division. So for that you have to use this truncate 8 by 3. Okay, right. And if you want to perform square root, 8 square. If you want to perform 8 square, you have to use double multiplication 2. Okay, 64. And I want only remainder. For remainder, you have to use this modulus 8 by 3. Means 2 will get remainder here. Okay, see 2. So these are different arithmetic operations. These are the. So you can check it here. Okay, this float, division, truncate, modulus, remainder, exponential means square root. Okay, 2 square root, division. Okay, these are the arithmetic operators. Next one is assignment operators. Assignment operators nothing but assigning a value to a variable. Okay, some assigning some value to a variable equal to 5. Single equal to means assigning this 5 value to this variable. Okay, x plus equal to 3 means equivalent to x equal to x plus 3. X minus equal to means equal to x equal to x minus 2. Okay, same thing, same like. Okay, same arithmetic operators but different assignment operators. Assignment means nothing, assigning a value to a variable. Okay, so these are the different assignment operators. And comparison operators. Comparison operators means comparing the values of two different operands, means x and y operands, comparing the value, and it returns true or false. If it satisfies, returns true, otherwise false. Okay, simple. Okay, say x equal to, these are the comparison operator: equal, double equal to, not equal to, greater than, less than, less than or equal to, greater than or equal to. Okay, so we'll see with an example. Suppose x is equal to 3, y is equal to 2. Single equal to means assignment, double equal to means comparison. Remember that. Okay, print x equal to y means double equal to means comparison here. Okay, so x equal to 5, 3 is equal to 4, 3 double equal to means 3 is not equal to 4. No, just check the output, it returns false here. But x less than y, 3 less than 4, returns true here. Okay, so true. Okay, so the comparison operator, whenever you are using comparison operator means you are comparison between two different operands. Okay, you are performing comparison between two different operands. Okay, x equal to y, x not equal to y. Okay, these are the comparison operators. Next thing is logical operators. Logical operators, x and y, x or y, not x. See, AND operator means true if both x and y are true. Okay, if both x and y are true, it returns true. If any either x or y are false, it returns false here. Okay, so true only if x and y are true, both are true. If any either false, it returns false here. Okay, but whether x or y, complete opposite of AND operator, or y, true if either x or y is true here. Okay, either x or y is true, it returns true. Okay, if both are x or y false, it returns false. Or operator, not x means if x is true, not x, returns false. Okay, we'll see more in coming exercises, these examples, logical operators. Next thing is identity operator. Identity operator means is operator, is not operator. X is y. True if x and y reference the same object. X is not y. True if x and y reference different objects. You'll see this one is operator. Objects class. Okay, is and is not operator. Identity operators are. And next thing is membership operator. Membership operator, in, not in operator. In operator, not in operator. Okay, in operator means mostly membership operator used in list, tuple, strings. Okay, so list, tuple, and dictionary sets. Okay, so we'll see why with an example. X in sequence. Okay, in operator. Suppose if you take some list here, list type, list is equal to 1 comma 2 comma 3. Okay, in operator returns true or false. Here print 1 in list. Okay, in operator use means 1 in list means 1 is there in list here. Okay, 1 element is there in list here. Just check the output now. So true. Okay, suppose if you 4 in list, if you check condition like 4 in list, 4 is not there in list here. Okay, returns false here. Okay, so same thing not in operator, opposite of in operator here. Okay, in operator, not in operator. These are membership operators. Next is bitwise operators. Bitwise operators are often used in low-level programming and manipulation of binary data. This perform operation individual bits with 8 integers. Okay, we'll see this bitwise operators advanced Python. This just bitwise operators. Just look at these examples and that. Okay. And next thing is the control statements. The control statements, there are different control statements are there. Conditional statements, transfer statements, iterative statements. What is conditional statements? Conditional statements, okay, in conditional statements means in programming are used to execute different blocks of code based on whether a specific condition evaluates true or false. Okay, there are different condition statements are there. If else, if fail, if else. We'll see with an example. What is if condition? Okay, if condition, suppose if you take x is equal to 5, okay, and if x, you are checking condition here. Okay, comparison operator. If x less than 6, okay, if x less than 6 here, print some x is less than 6. Simple. Okay, x is less than 6 here. Okay, means x is equal to 5 here x assigned to 5 here. A comparison operator returns true or false. Okay, if it satisfies the condition true here, okay, so it executes this print statement. So x is less than 6, but what if x greater than 5 here? Suppose if x is equal to 7 is given, 7 is greater than 6 here. Okay, but it won't execute now, just execute here. But I want execution though is x equals 7. For that you have to use here else part here. Okay, else part print here x is greater than 6. Else part executes if condition, if returns false here, if condition returns false, else part will execute here. Okay, see, x is greater than 6. Okay, if condition true, this print statement executes. If condition is false, else part is executed. But I want to check multiple conditions. To check multiple condition, you have to use elif. Okay, elif. If elif x equal to 6, just print x is equal to 6. Okay, x is equal to 6. Simple. X equal to 6. Right. Okay, elif condition. To check multiple conditions, you have to use elif statements here. Okay, so x is greater than 6 here. Suppose if you return x equals 6 here, simple. So x equal to 6 here. Okay, so multiple, you can check multiple elif statements used to check multiple conditions. Okay, to check multiple conditions, if this satisfies this condition, it checks. Okay, if this satisfies another elif conditions, if any if conditions not satisfies, it goes to the else condition. Okay, so that's about the if, elif and else conditions. Okay, condition statements means it executes different blocks of code based on whether a specific condition evaluates to true or false. Okay, and next thing is iterative statements. Iterative statements are in programming are used to repeatedly execute a block of code. If you want to execute repeatedly a block of code, okay, you have to use iterative statements. For and while, for loop. Okay, and also there is a range function. Is a range function. If you want to execute sequence of numbers, we have to use range function. We'll see this one, range function. Simple. Suppose for I in range of, okay, for I in range of 10, print I, means it executes 0 to 9. Okay, range function. Okay, if you n number 0 to n minus 1, it executes 0 to n minus 1, means 0 to 9. See 0 1 2 3 4 5 and 9. So I don't want the print cursor move to the next line. I want in the same line. So for that you have to use n parameter. I told you, okay, n parameter. Simple. Just execute now. See 1 0 1 2 3 0 to 1 to 9. So if I want to execute only first 5 numbers, means first you have to use 5 here. Okay, 0 to n minus 1 means 0 to 4. 0 1 2 3 4. Okay. So that's the range function. Okay, if you want to execute sequence of numbers, you have to use this range function. Okay, for loop, for variable in range function. Okay, that's about the for loop here. And next thing is while loop here. While loop executes. So next while loop we will see here. Suppose if you count equal to 0, take count equal to 0. Okay, and while count less than 5. Okay, while count less than 5, print, or sorry, while I print count is equal to count plus 1, or count plus equal count is equal to count plus 1. Okay, count 0 less than 5. Okay, repeat 1, print count 1 2 3 4. Okay, satisfied until see 0 1 2 3 4 here. Okay, so while condition means mostly we use for loop only. While condition is rarely used in the Python. While only because while is there is a infinity loop problem is there in while loop, because it's only it until false, it while condition executes until it returns false. Okay, so that's the reason. And next thing is transfer statements: break, continue, pass. Break and continue, pass. The transfer statements in programming are used to control the flow of execution by transferring control from one part of program to the another part of program. With example, we will say what is break and continue. Difference between break and continue. Okay, we will use for loop only for this one. For I in range 10. For I in range 10, if check condition, if I is equal to 5, break. Okay, break, print I. Okay, suppose execute this one. See 0 1 2 comma 2 comma 3 comma 4. If you want in same line, and is equal to see 0 1 2 3 4 only. Okay, observe here 0 if it check the condition. Okay, what 10 sequence of numbers, when I is equal to 5, it breaks the loop here. Okay, it won't execute entire loop. Okay, it breaks between loop, and rest of the loop won't be executed here. Rest of the loop won't be executed here. Okay, in break statements nothing but rest of the iterations won't be executed if certain conditions met here. That's about the break one. What's about the continue? See, next we will see an example for x in range 10. Same example, range 10, if I is equal to 5. Continue, print I. Okay, print I, comma, and is equal to, see, observe, sorry, print x here. Okay, sorry, x here. Okay, sorry, x and x here. Okay, just check the output now. See, break it when I is equal to 5, it takes the loop. Okay, whereas when x is equal to 5, if you use continuous statements, just it skips the 5 part only. Okay, rest of the loop it won't be terminated, it executes only the certain condition, it skips the matching condition, and rest of the loop it will iterate, rest of the loop it executes. Okay, whereas in break statement it breaks the loop. Okay, break statement as it breaks the loop. Okay, continuous statements only it skips the current part of the iterations, the rest of the iterations it executes. Okay, that's about the difference between break and continue here. You can check here. Okay, and next thing is pass is there. Another thing, pass pass. So z is equal to 10, take it, and if z equal to 10, okay, pass, simple, pass. Okay, and else part is there, else part, print pass is executed, whatever, okay, pass is executed, whatever, okay, executed. Just check output here. See, z is equal to 10 because it satisfies the condition, but it won't print any statements. Okay, if there are certain conditions, if certain conditions like this, you have to use this pass here. Okay, simple one. So that's about the pass statement here. So iterative statements. So examples as given, syntaxes examples as given here. Just look into it. Okay, see, pass acts as a placeholder and does nothing. It is often used when a statement is syntactically required but don't want any action to be taken. Okay, so okay, that's about the, because nothing executes. Okay, if though it's true, if certain condition is there, if you don't want to execute any print statement though condition is true, you have to use this pass statement here. Okay, so these are the different conditional statements, transfer statements and iterative statements. What are Python data structures? Okay, what is data structure? Data structure is a way of organizing and storing data in computer's memory to efficiently perform operations on the data. Okay, so to perform some operations you need some data structure. Okay, to perform some operation with some data structure is nothing but these are the data structures examples: list, tuple, sets, strings, dictionaries, arrays, dequeus also there. So majorly we will see these data structures: list, tuple, sets, strings and dictionaries are the Python data structures. We can call list, tuple and strings are called sequential data types. Okay, we can also call list, tuple and strings are list sequential data types. So there are these are major differences between these different data structures: mutable or immutable, ordered, indexing, duplicate elements. What is mutable? What is immutable means it cannot be changed after creation. Once, suppose if you take a string, once you if you create a string variable, once you change it cannot be changed after creation, means it cannot be modified after you create a string variable. That's called immutable. Whereas mutable means can be modified after creation. Once you create a list or sets or dictionary, it can be modified after creation, whereas strings and tuples are immutable here. Okay, ordered means it maintains order. From Python 3.7 versions, dictionary is also ordered. Okay, strings, list and tuples are maintains order. Sets and dictionaries do not guarantee order, but from Python 3.7 versions, dictionaries are ordered here. Okay, indexing, arrays are array not arrays, indexings are zero based here. Okay, if you want to access individual elements, you can access through index here. Okay, so strings, list and tuples allow indexing to access individual elements, where sets are unordered. That's why we do not support accessing. Okay, and dictionaries uses key to access values. And duplicate elements, repetition of elements. Okay, repetition of same elements in a given list or tuple or whatever. Sets and dictionaries do not allow duplicate elements or keys. In strings, list and tuples can contain duplicate elements. These are the types here: str, list, tuple, set, dictionary. Okay, so we'll see one by one with an example major differences. These major differences we will see one by one with examples. So first see this. Look at this one. Look at this table. Just strings, why string are immutable. Okay, we'll see with an example why strings are immutable. We'll see here. Okay, so take an example: string is equal to suppose take hello Python. Okay, just some string. Okay, you take a string and store in this variable. Okay, hello Python. So hello Python, print it string. Okay, print string here. Okay, see hello Python, and also see strings are ordered here. Okay, exactly same how you enter this input, and exactly the same way we got the output here. Okay, ordered, exact order. Okay, maintain the strings maintain ordered. I want to access this h element, h character in the string. Sorry, I want to access this h character. So print simple index. Through index you can access 0. Okay, square bracket 0. If you want to access individual elements through indexing, you can access the individual characters in a string. Okay, so observe here, check the output, see h here. Okay, if you want to access e means just use 1 here. Okay, 0 1 e. Okay, so indexing nothing but accessing individual characters in a string and elements in a list or tuple. Okay, so accessing individual characters here using string here, 0 position h, 1 position e, second, third, fourth positions like that. Okay, thus you can so strings arrays, and also strings allow duplicates here. See double L is here. Strings allow duplicate members. See observe here. Okay, strings are immutable. Immutables we can see here. So I want to access I want to change this h to a here. I want to change this h to a. So how you show me string of 0 is equal to a. See, you will get error here. Okay, so observe here, you get error, print str, so you'll get error. See, string object does not support item assignment. Okay, type error, you get type error because you can't change the string here. Okay, whatever you created string here variable, you cannot change it. You cannot change the string because strings are immutable here. Okay, observe, see, strings are immutable. See, strings are tuples are immutable because cannot be changed after creation. Any operation that appear to modify a single string or tuple actually creates a new string. If you want to change a string here, if you want to change some string name here, so you can use like this one. Okay, instead of string 0, y is equal to a plus, you can use array slice operator, x of 1:0. Okay, so not x here, string here. Okay, string of 1:0, print string, print y. So a string of 1:0 means it's an array slice operator. 1:0 means except first character it returns rest of the string. Okay, except first character it returns rest of the characters of a string. 2:0 means except two characters return rest of the string here. Okay, so 1:0 we are adding a plus, and so we are adding this ALLO Python. Okay, just observe here, just comment this one. So now observe, see, hello Python, we got the indexing 0 character hello Python a here. Okay, a hello, y is equal to a plus string of 1 of 0 here. Okay, string, wait just a minute. Oh sorry, here not 1:0, just here 1:, that's it. Okay, 1:, just leave it was just 1:, means it returns rest of the first except first character returns rest of the characters. 2:, means except two characters returns rest of the characters. Okay, so just now check the output now. See, hello Python, hello Python here. Okay, but you can observe here, okay, strings are immutable. So strings, because if you want to modify the string, it new variable is created here, y here. Okay, string, because you cannot change the string variable here now. Hello Python cannot change, you can't change the string variable. If you want to change it, you have to change like this one, another variable, because strings are immutable, right? So observe here, strings are immutable, strings are ordered, strings are indexed, strings are duplicate members, double L here. Okay, so that's about the string here. Next thing, list here is a next list. Lists are mutable. Lists are denoted by square brackets. Lists are denoted by square brackets. It allow all data types 1, 2, 3, 2. Okay, string, it allows string, it allows boolean type, it allows float. Okay, strings, list allow all data type elements, individual elements, all data type elements list allows. Just print here list. Okay, now check the output. See, 1, 2, 3, 4, exactly same. List follows ordered. Okay, exactly same we got here. And also list allow duplicate members 3, 3. List allow duplicate members. See, 1, list allow duplicate elements. Okay, 1, 2, 3, 3, and list are ordered here. Exactly same output we got it here. And also list are indexed here. Okay, so suppose if you want to access first element, I want to access one element, print list of 0. Observe 1 here. Okay, and lists are mutable. Mutable means you can modify the variable. Okay, you can suppose if I want to modify this one number, I want to replace this 1 to 10. Observe list of, okay, list of 0 is equal to 10. Okay, so now observe print list. See, 1, 10. See, observe the first element here replaced with 10 without changing the variable name. That means lists are mutable here. Okay, you can modify after creation. You can modify the list variables after creation also. So that's about the list. Here lists are mutable, ordered, it allow duplicate members, indexed here. Okay, so that's about the list here. Next is tuple. Tuple also allows, see, tuple it can store any data type, string, list, set, tuple int in dictionary. List also store any data types, but tuples are immutable here. Okay, simple, same like list only, but difference is tuples are immutable. Tuples are denoted by, okay, tuples are denoted by parenthesis like this one. It allow duplicate members. Tuples won't allow tuples allow duplicate members. Tuples also allow duplicate members 1 comma 2 comma 3 comma 3. It also allows all data types, boolean, whatever, okay, boolean, string, float, all data types. Observe printf, right? So tuples are also ordered exactly same output we got it. And also if tuple want to change, if you want to change the first element, you can also, okay, suppose indexing is possible in tuple or top of 0. I want to access first element. See, 1 you can access the first element. And if you want to change the first element, if you want to change the modifier, change the first element, observe here is equal to 3. So you'll get error here because tuples are immutable. You cannot change after creating the tuple here, okay? So that's about the tuple. And next thing is set. Sets are denoted by flower brackets, okay? Sets, see, sets allow can store any data types int, string, tuple, but not list, set, dictionary, okay? Sets only data types int, string and tuple only. Sets only store. It doesn't store list and set. And sets are unordered here, okay? Suppose if you write 1 comma 2 comma 5, 1 comma 2 comma 5, 1 comma 2 comma 5 comma 3, just observe print set. Sets are unordered, okay? Sets are unordered. Observe your output here. See, 1 2 3 5. So 1 2 3 5. See, we entered 1 2 5 3, but we got the output 1 2 3 5. So because it's unordered, sets doesn't maintain order here, okay? And also sets doesn't allow duplicate members. Comma 3. So it's 3 comma 3. Just check the output. See, it doesn't allow duplicate members. And also sets are not indexed because unordered are not indexed here set, but sets are mutable here because if you want to delete, suppose if you want to delete 3 number, you can use del methods here. S dot del, okay, s dot observe here. If I want to remove SR mutable because I want to remove this third element, just s dot remove 3, print s, okay? Just check the output. See, third element has been removed here, okay? 3, number 3. So like that means you can modify the sets here. Means sets are mutable here, okay? Sets are mutable. Sets are unordered. Sets unordered means sets cannot index, and sets doesn't allow duplicate members, okay? So you have to remember that one. You can also update here. Simple. You can update by s dot update method is there. You can add new elements. Update some 7 comma 8. Print s. See, 7 comma 8, okay? Means same element you can add, update it, you can remove also. So that means sets are mutable here, okay? But set doesn't allow duplicate members. So that's about the sets here. Next thing is dictionary. From dictionary, if you want to store a dot and key value pairs, you have to use dictionary here. Simple. D is equal to D is equal to A colon 1 B colon 2 comma C colon 3. Okay, A is nothing but key, 1 is value, colon left side is a key, colon right side is a value here, okay? Key value pairs. If you want to store a data in a key value pairs, you have to use this dictionary. And dictionaries are ordered from 3.7 versions, okay? From 3.7 version onwards, dictionaries are ordered. Even, okay? Before the earlier 3.7 versions, you have to import collection module called unordered dict something, ordered dict. So you have to use that. If you want to maintain your dictionary order, you have to import that module, okay? So but now dictionaries are but I'm using 3.7 version, so now dictionaries are ordered here, okay? Dictionaries are ordered. Dictionary stores in key value pairs. If you want to access dictionary individual items, and also dictionaries are mutable here, okay? See, dictionaries are mutable, unordered. Unordered means earlier 3.1 version, but from 3.7 version it is ordered. It does not allow duplicate keys, but values can be duplicate. So, and also inside of dictionary keys can be key can be integer, string, and tuple only, but values can be of any data type here. Okay, and doesn't allow duplicate keys here. Okay, dictionary doesn't allow duplicate keys. Observe here, values can be duplicate. So observe here, comma D colon 3, because same value I am writing, so values can be duplicate. Suppose if I am writing instead of C, instead of B, if I am written D here, because keys are not keys doesn't allow duplicate. Check the output, A D3 C3. Okay, A D3 C3, D2 is not there here. Okay, so because it doesn't allow duplicate keys, but values can be duplicate here. Okay, values can be duplicate here. Okay, and also dictionaries are not indexed, but if you want to access values, you can access through keys. How means, suppose like this one, print D means dictionary here of A. Okay, I want to access one, you want to access D of key here. Okay, in square brackets you have to write key, dictionary of key, you will get value. See, 1 here. Okay, you can access like this in dictionary. And also if you want to access individual item, if you want to access only items, D dot items. That means if you want to access only keys, you have to write like this, D dot items. Observe here. Okay, see, D dot items means keys and values. If you want to access keys and values, you have to use D dot items. If you want to access only keys, you have to use keys here. Okay, sorry, keys here, dig dot key. If you want to access keys, you have to use dig dot keys, and if you want to access values, you have to use print dot dig dot values, d dot values. See, values here 1 2 3 3. If you want to access individual elements, you have to use for loop here, for k comma v in dig dot items. That means in items, keys and values will be there. Okay, so print key means print key k comma, and k means the dig dot items, keys and values are there, keys stored in k, values stored in v. So if you want to read only keys, you have to use k here. Okay, just a minute. D dot items here, not D dot items, sorry, D dot items. Check the output here. See, A B C D. If you want to access values, v here. Okay, see, 1 2 3 3. Okay, and also dictionaries are mutable here. Mutable means, check here, suppose I want to delete this A item, I want to delete this A key here, so simple use del element D of A. Okay, and print D. Okay, just check the output now. See, A is not there here. Okay, check here. So these dictionaries are mutable here. Okay, you can change the dictionary keys. Okay, dictionary change, you can delete or you can update or you can use these dictionaries as mutable here. Okay, so that's the main difference here. String, list, tuples, major difference between these 5 data structures. So we can, I have given output also, you can check it here. And next is functions. We will see here. What are the functions? Describe functions in Python. What are the functions? So in general, functions are reusable blocks of code that perform a specific task. Reusable blocks of code. Why we use functions means, generally, so it performs some operation and returns some value. Okay, some value, and that value we can use in anywhere in the program. Okay, reusable. Okay, and also they help in organizing code, making it more readable, modular, and easier to maintain. Okay, and in general, functions returns a value. Okay, functions returns a value in simple words. Okay, and that value can be reusable anywhere, any part of the code. Okay, and next thing is, you have to remember indentation. Indentation in Python in generally refers to the spaces at the beginning of the code line. Okay, Python uses indentation to indicate a block of code. In generally, if you see Java or C, flower brackets represents the block of code. Okay, but here in Python, indentation means spaces beginning at the beginning of line code. If you see the example, So if you see this example, definition, display, print, there is lines are there in before, there is some space are there, print. So nothing but a indentation, okay, because it represents this block of code, okay, function code, that is. So we'll see, okay, that's a simple function definition. This is a function definition here. If you want to define a function in Python, you have to start with def. Def means def and display function name here, okay, function name colon and some print hello Python display here, okay. So just we'll copy this one, output, okay, just print it here, hello Python, okay, simple. This is a function name, simple function name, okay. Display function name is a display name is a definition, function name, parenthesis followed by colon, and here you have to follow indentation represents a block of a code, okay. So it's a part of a function, we can say, simple. And if you want to call the function, just call the display here, okay, simple one. This is called the display here. Just see, you can check here, see, definition keyword is used to define a function name display identifies the function, parameters, input values of function, parameters, we did not return we did not write parameters here, and colon indicates the start of the function body, doc string, optional documentation describe the function here, okay, and function body prints hello Python, okay. This code executed when the function is called, okay. So this is simple function definition. So if you want to write a function definition, function name colon and the parenthesis colon and the documentation, okay, docs. The simple syntax of function definition. Next we will see function with parameters. If you want to send parameters nothing but here parameters a placeholder for the actual value passed when calling the function, okay. These are parameters, simple one. So pass any parameters here, nothing but a variables. You can pass any you can pass string or integer or whatever. So I am passing one string and one integer and call with the parameters now. Display arguments now, okay. Name, give any name, Python name you are given, or any hello Python whatever, Bob name, and comma x, you can give 3.7, okay, version name. Just execute the output here, see hello Python Bob 3.7, okay. We are passing the parameters here. Parameters, name of comma x are parameters and Bob 3.7 arguments, okay. So what is the difference between parameters and the arguments here? So check here. So parameters are variables used in a function definition. Parameters are this name comma x are parameters are used in function definition, while arguments are actual values passed to the function when it is called, okay. Arguments are actual values, these values Python 3.7 values passed to the function when it is called. In simple words, parameters are the variables, arguments are the values passed to the function, okay, function parameters. So that's a simple difference, arguments and parameters, functions with parameters, and also function with return value. There is another statement, is a return statement. We will see with an example that return statement. What's the return statement? By adding two numbers, okay. So define add function, okay. Add function takes some two parameters a comma b, okay. A comma b, c is equal to a plus b, or print like something like that, print sum is a plus b, simple words, okay. We are not returning function here now. So if you call add 2 comma 3 like this one, add 2 comma 3 without using returning, this program is about, okay. See, check output, sum is 5 here, okay. Just we are passing arguments to this parameters a comma b variable, just it returning this print sum equal a plus b. Now with print function we will see now here, definition add to same parameters, take a comma b or x comma y, whatever, x comma y colon, use return statement here, return x plus y, okay, x plus y. Now return function returns a value. I told you function returns a value, function returns this addition numbers, okay. So if you want to call this return value, you have to store this return value in some variable here, okay. So sum is equal to, okay, sum is equal to add to 5 comma 6, okay, 5 comma 2 comma 3, 2 comma 3, and print it here, print sum. Okay, so check the output now. See, sum is 5, here also 5 here. Okay, so I hope you understand return statement without using return. This function, first one is a function without using return statement, and second one is a with using read statement. Okay, with using return statement. So in first we didn't use any return, just we are printing directly the, okay, we are printing directly in the body section of the function body, and just we are calling with the arguments here. Just here we are returning the values. Okay, returning the this some expression here. Okay, returning the expression, and that expression has written some value. That value has stored the sum here, and printing the sum here. Okay, whenever you use return statement, whenever the function returns some value, we have to store that in first variable. Okay, okay, and that we have to print it here. Okay, whenever a function returns a value using return statement, it returns some value. That value have to store in some variable. Okay, and print that variable. It's simple. If you want to use return statement, means if you are directly printing in a function body, no need, just call the function name with parameters. Okay, simple. That's about the function with parameter return value. Okay, function with return value, and also there will be default parameters also there. So default parameters are nothing but, suppose if you did not pass here, suppose if you pass here a b is equal to 5, default, this is a default parameter, and you did not pass to 3 here, add 2, still it executes. Okay, sum is 7, 5 plus 2. Okay, otherwise if you did not pass any argument here, just it returns, gives error. So but for that you have to write here default value. Okay, there's a default value arguments here. Okay, b is equal to 5, default. If you did not write any argument here, this default or default parameter add function takes. Okay, so that's simple default one. And next thing is function with return value finished, and variable length arguments. Okay, variable, see, return statement is sends a value back to the caller, simple definition. Variable length arguments. Okay, so we'll use multiply here. Variable length arguments nothing but we'll use multiply here. Suppose you don't know how many arguments are there. Okay, so before program you know the parameters a comma b, but here we don't know the arguments. So for that you have to write simple star numbers or star args, whatever name. Okay, star numbers, whatever, single star means you don't know how many arguments are there, so for that you have to use star here. Okay, so result is equal to 1, multiplication, this one program result is equal to 1, and for num in numbers means this star numbers. Okay, this numbers, so result is equal to result into is equal to result equal to 1 here. Okay, simple, result equal to result into 1, you know, result equal to 1 here. Okay, or else I'll write like this, result is equal to result into 1. Okay, and then return result here. Okay, sorry, not result is equal num here. Okay, result is equal to, sorry, num is equal to, now for num in numbers, result is equal to num into results here, something here, result equal to result into num, simple. Okay, result is equal to result into num. Okay, and then return result here. Okay, return result, simple. Okay, and we are returning function now, and we are the return function we have to store in some variable. Okay, so use some, okay, multi whatever variable. Okay, multi is equal to mul 2 comma 3. Okay, 2 comma 3, print multi. So how about 2 into 3 equal to 6 here, answer should be 6 here. Okay, 6, see, because this mul 2 comma 3 into number, we are passing these arguments into these parameters. Okay, each into numbers nothing but a parameter. If you don't know the parameter, how many parameters are coming, you don't know the how many arguments are coming from to the parameters, so for that you have to write it args, okay, into numbers or args, whatever. Arguments means numbers value. Suppose if you return multiple arguments equal to mul 2 comma 3 comma 6 multi 2, so we are passing 3 arguments here. So we are passing 3 arguments here, okay, passing 3 arguments, passing 2 arguments. You don't know how many arguments are there, so for that you have to write star numbers here in parameters. Okay, just check the output here. See 36, 6 comma 36. Okay, so that's about the multi variable length arguments. Okay, variable length arguments. So arguments collect any number of positional arguments into a tuple. Observe here. Okay, and next thing is keyword arguments. Double star arguments means if argument contain dictionary format, if you want your keywords argument in dictionary format, you can write here keyword arguments. Okay, so just simple one, passing keyword arguments as a parameter. Just check the output. Simple one, this one, simple one. See, print keyword. See, you are passing dictionary. If you are passing dictionary as an argument, you can write here double star kw arguments. Okay, you can write any number of arguments in the method name. Okay, see, keywords arguments in dictionary format, name alias age 25. Okay, 25 double star, you edit double into keyword arguments means if your arguments coming as in dictionary, you can use these double or keyword arguments. Okay, any number of arguments for dictionary type. For the keyword arguments, see, double star keyword allows a function to accept any number of keyword arguments, and keyword argument syntax is a function definition collects additional keyword arguments into a dictionary here. Okay, and next thing is lambda function. Okay, so now, as of now we are getting arguments from the individual variables. Okay, we are passing just variable names a comma b, okay, b comma c, like that only. So now if we pass a list here, okay, if we pass a list as a parameter, okay, individual variables just now we are passing, now we are passing as a list. If how you pass it, you will see. Okay, simple one, a lambda function. A lambda function nothing but in Python is a consensus way to create an anonymous function. Lambda function is nothing but called as anonymous function, means function without a name. As of now we have name, but here lambda function means function without a name. Okay, anonymous function. So the function uses lambda keyword followed a list of parameters colon expression. This is the syntax here, lambda parameters colon expression. We'll see with example with lambda expression and without lambda expression, so you can understand easily. Okay, so simple adding two numbers will take. Okay, simple one. So now without lambda expression, definition, add 2 comma 3 or a comma b or a comma b. Okay, okay, return a plus b. Okay, return a plus b. So sum is equal to add 2 comma 3 print sum. Okay, so this is without lambda function, adding the numbers here. Okay, without using lambda function, normal function it is. Now we use lambda function. Okay, so just use add 2 is equal to lambda. What's the parameters here? A comma b colon expression. What's the expression? A plus b. Okay, simple, that's it. And just call add 2 is equal to add 2 or sum 2 is equal to add 2 of 2 comma 3 print sum 2. Simple one. See, 5 same. See, without using lambda function, with using lambda function, the difference you can observe here. In normal function we have function name. In lambda function you don't have function name. Okay, in normal function there is return statement. In lambda function there is no return statement. Implicitly it called return statement. Okay, lambda function implicitly it called return statement. Okay, so only parameters colon expression, lambda parameter colon expression, and I have to store in the variable name. Okay, simple one. Okay, in normal function consists of name, function name and return statements, whereas lambda doesn't have function name and also return statement. Okay, but implicitly it calls return statement here. Okay, in lambda function. So that's about the lambda. See, so the result of expression is implicitly written from the lambda function here. Okay, and lambda function and adding two numbers. Next is the map function. Map function. Okay, map function in Python is used to apply specified function to all the items in a iterable and returns in an iterator. Okay, that produces a result. So this is the syntax here. Okay, map function comma iterable. Okay, map function comma iterable. We are applying function to all items in an iterable. Okay, applying function to the all elements in the iterable, that is list, tuple or string, and returns a iterator object. Okay, it returns an iterator object. We'll see with an example. This is an example, map function comma iterable. I am just using this control C comma. So just see map function comma iterable. Okay, so just how we what is a map function, we'll see with an example now. Take a list here. Okay, list is equal to 1 comma 2 comma 3. We want to perform square for this list elements. Okay, for that we have to use first function, define square of x. Okay, and return x square. Okay, x square means x 2. Okay, x square. Okay, return x square. So we define a function now. Okay, to define square x, this is a function, square is a function now, and we are using map now. Okay, map function. Okay, so map means square el is equal to map. What's the first parameter of map? Function. What's the function name? Square. What's the second parameter? Iterable. What is a iterable here? List here. Okay, list here, pass list here. Okay, list. So we are performing square to the each and every element of the list here. Okay, simple words, we are performing square function to the each and element of the list here, map function. Okay, and returns iterable object here. Okay, it returns iterable object. Observe here, print square real here. Okay, square real, just observe it returns iterable object here. Simple observe. See, map object here, it returns iterable object, map object here. Okay, but I want to convert it this, we can convert this map object into list here. How? Just using inbuilt function list here. Simple, list map. This just check the output now. See, 149, square of 1 2 3 equal 149. Okay, I hope you understand. You have to remember the syntax. Map function iterable. Function means each function performing on these iterable elements. Okay, iterable elements means list or tuple or set or whatever. Okay, so you can convert, you can also convert it not a list, you can convert it into tuple, set. Okay, just check it here. And also you can use lambda function too. Instead of function here, you can use a lambda function too. That also we will see here. You can use lambda function in terms of function. We can use lambda function too. So first we will see here, square 2 is equal to map lambda. Okay, lambda. What's the argument? What's the parameter? X. What's the expression here? X into 2. Argument colon expression. Simple. Okay, comma. What's the iterable? List here. Okay, list, and I have to convert into list here. Okay, list inbuilt function. Print square 2. Simple. Check the output now. Okay, see, say 149 149. Okay, by using lambda function. You can use normal function or lambda function, directly lambda function. Okay, lambda or parameters colon expression. Okay, so that's simple about the functions. These are the simple functions. There are so many are there, function methods, decorators, generators. We will see that in advanced Python. I hope these are simple parameters, how to pass multiple parameters, how to pass iterators. Okay, so I hope you understand this functionality. 10th one, here we will see what are different file handling modes. Here What is file handling mode means? It's basically giving permission. So for read, write, or append a data to a file. Okay, you can also use combine or combination of them. So read it means you can read and write to the file. These are the different modes here. You can check the table here. Text file mode, binary file mode. Binary file mode nothing but if you want to write a data in images, if you want to read data from images or videos, okay, binary file mode. If you want to write a characters or read a characters using text file mode, okay. So R means read mode here, okay. Read mode means you are just reading a data from the file and just printing that file, okay. This file must exist, the file must exist, otherwise Python ASN file not found error. Or W means write mode here, okay. Text file mode. W means it means if file not exists, file is created. If file not exists, file is created. If file exists, Python will truncate exist data and overwrite the file, okay. If file is not there, it creates a new file. If file already exists, it deletes that file and writes new data, okay. Append means file is in write mode only, new data will be added at the end of the existing data, okay. It won't delete the data, okay. Just append the data to the already existing data. No overwriting takes place in append mode, okay. If you want to update the data, you have to use A mode. If you want to write the data, you have to use W mode. Read the data to read more mode, okay. B means binary here. Binary means if you want to read the text, if you want to read the images, audio, video, okay. So like that, okay. This is a binary mode, okay. B means binary. If the data consists of images, audio, video, you can have to use binary file mode. If data consists of characters, you have to use text file mode. Simple. R plus means file must exist, otherwise error is right. Both reading and writing take place. If you want both read as well as write, okay, you have to use R plus mode. And also RW plus means file is created. If not exist, if exists data will be truncated. Both read and write are all for this one also. A plus means just append the data, okay, read and write both. So we'll see only this read, write, append mode, okay, with examples. So there are some functions and methods are there to read a data from the file. We'll see what are, okay. Simple. See, this new.txt is there. So some text file here, some data is in new.txt file, some data is there. So I want to read the data and also execute in the terminal, okay. And also I want to read the data and just execute in the terminal, just show in the terminal. That's it. Simple. For that you have to use open function here. Open mode, open. See, open. Because so many parameters are there, we have to use two parameters here. File means file name. Which file name you want to read it? I want to read new.txt, okay. New.txt file, first parameter, and second parameter is which mode, read mode, just reading the data, okay. Read mode, that's it, okay. So file was created here. We successfully open the file and I want to read the data and I have to store in some variable, no. So just take a variable. There is a read method, is a read method. There are so many methods, read out, read lines, okay. Read lines method is if you want to convert the data into list, you have to use read line method. Just read the data and displace it, okay. So we use read method here. F dot means file dot read method and storing this variable and just print it. Print RC and you have to close it, okay. When you open the file, you compulsory have to close it, okay. Close it. Close method is compulsory. Just check the output. That's it. See, the data new.txt here and the data has been displayed successfully here, okay. Python supports. Okay, and not only that, we can use a with statement instead of opening and closing the file. We can use a with statement also, because using the with statement is recommended as it simplifies the code and ensures proper handling of file resources, including closing the file. Okay, so if you use with statement, you don't need to close the file. Okay, automatically it closes the file, and also it's the best practice in Python for working with files and other resources that need to be explicitly closed. Okay, even exception occurs, the file will be closed. Okay, that better you have to use a with statement here. Simple instead of F here, so just use it with simple with open as F. Okay, the syntax here. Okay, as file name. Simple. Just use indentation lines. No need of close here. Okay, simple. That's it. Simple. Just check the output here. Same. Okay, same output here. If you use with statement, no need to close the file. Okay, automatically interpreter closes the file here. Okay, even exception occurs also, it closes the file. That's about the opening the file, reading the file. Now I want to write the file. Just in read mode, okay. Now I want to write the file. I want to write some data to the new.txt or another new file, okay. So for that, just use with statement only with open mode. Write.txt new file here. We will create a new file, okay. And use instead of use w here, okay. W as f only, file name whatever, and use write method here, okay. See f dot write. Okay, this is write mode. Write some text, whatever. Okay, this is write mode. Okay, we are creating new file and we are writing some data there. This is write mode. Okay, it is write mode, and just use print here. Simple. Just statement. Okay, content submitted successfully. Just print that. Okay, content submitted successfully. Simple. Just check the output here. Write mode here. Okay, write dot text. See, this is write mode. Okay, that's about write mode. Simple. Okay, you have to change the write mode here. Okay, and next is append mode. A mode. Append mode means it's appends the data. Some if you want to write some data to this write dot text, you have to use append mode here. Okay, so just use append mode. Just f dot write same method. Append mode. Okay, content successfully appended. Successfully appended. Or whatever. Okay, okay. Just check the output now. Content successfully. Just check write dot text again. See, this is append mode. Okay. See, this is append mode. This is write mode. This is append mode. Successfully, if you want to, write, if you want to update a data, also you have to use this append mode. Okay, read write append mode. This is simple one. Read method and write method is there. So successfully, and you have to use binary method also. Binary method. Okay, binary method. If you want to read the data, binary means read. Binary data stores entire data in the form of bytes. So binary can be used to store text, images, audio, video. Okay, if you want to work with audio and video, you have to use this binary mode. Okay, simple one. Just I will copy this one and I'll show. Simple one. Just check the output now. Control V. So I'm opening this JPG. Okay, this river image is there. River image is there. I'm copying it to the just another file. Okay, copying one image into the another image. F2 equal to open. Read binary. Read the file. Write binary. Writes the file. Okay. So bytes is called f1 dot read. Suppose if you film dot bytes here, see how it will print here. Okay, simply check the output. Okay, just byte mode. See byte mode. See the data will be like this one. Okay. So if you want to read the binary data, this data will be like this one. But if you want to copy that binary data to the another file, just you have to use f2 dot write byte. Simple. Close method and this close method. Okay, just check the output now. Simple one, and there's a copy is there. Yeah, copy.jpg. So copy images, copy. Okay. So if you want to copy images from one file to another, you have to write like this one. Just okay, dot read the method and just write the method. Read method and write method. Simple. Read method you have to use from the f1 file, and write method you have to use in the f2 because this is a read binary mode, WB write binary mode. Okay. That's about the read write binary. So there is another modes also there. Read binary plus R plus W plus A plus. This we will see in advanced mode. This is simple. Okay. File handling. How you write the data, read the data, and append the data, and also how to read and write the binary data. Okay. And we will see now exceptions. Okay. Exceptions here. So what is exception? Okay. What are the exceptions in Python? So errors detected during execution are called nothing but exceptions. Errors detected during execution are called exceptions. Simple words. Okay. So generally errors interrupt the flow of the execution of a program. So if you don't want to interrupt the flow of the execution of a program, we have to handle that exceptions. How you handle this exception means using try and catch blocks. Okay. Using try and, so not try and except blocks. Catch block is in Java, try and except blocks in Python. Okay. Try and except block. What's the try block means? Lets you test a block of code for errors. Except block lets you handle the error. Else block lets you execute code when there is no errors. So we'll see with an example. So there are some exception types are there. Exception in Python are represented by classes. Each type of exception is class that inherits from the base class. Okay, base exception. Common built-in exception classes. Type error, value error. We'll see what are type error, what are this one. So we'll see with example. You'll understand what are exceptions. Okay. So to stop the flow of execution of program, we have to handle the exceptions using try and except blocks. We can handle that exceptions. Okay, how we will see here. Suppose take a variable here, result is equal to, okay, add two numbers here, 10 or string 10 plus 5. Okay, so print result. Let's check the output now. See, it raises errors because Python is a dynamic typed languages. So whenever if you want to add string with integer, it raises error here. Okay, so type error raises. So generally, if there is a big program, so it stops the flow of execution. But I don't want to stop the flow of execution. We have to handle these errors. So using try and except block, we have to handle these exceptions. Okay. So try block lets to test the block of code. In try block, we have to write the which code you have to test it. Okay. So this we have to touch it. So try and except blocks or try and except blocks we have to write compulsory. Except block, except blocks handles the error. Okay. So which error it is? So which error is this? Type error. Okay. So type error as e. Okay. Save that error in this e variable and print that e variable. Okay. Print the error. Formatted literal. Okay. You know format literal was I told you e. Okay. So and also just okay, I hope understand. Okay, we try block handles the block of a code for errors. So try block tests the block of a code for errors. Except block handles the error. Okay, so this way we can handle the exceptions here. Just execute this. See, can only concentrate on string, not into string here. Okay, this is a simple error. Suppose if you want to, if there is no error, you have to write in else part. Okay, else block lets to execute code when there is no error. If there is no error, else part will execute it. Just print result. Okay. So if you take out this string, so there will be no error here. Okay, simple. Execute now. Okay, see 15 because there is no error. Else block will execute it. If there is an error, except block will execute it. Okay, except block we have to handle that error. Okay, try block we have to test the error. So that nothing but this way you have to handle these exceptions. Okay, so you can suppose you can write multiple exceptions also with single try block. You can write multiple exceptions. Okay, so suppose if there is 10 by 0 is there, so is it 0 division by error? Okay, except 0 division error as e. Simple, same thing. Print f e. Okay, simple. Okay, it's a type error. If it is type error, it raises type error. If it is 0 division error, it raises 0 division error. Okay, so 10 by 0 is just execute output now. So division by 0 error it is. Okay, because it is a division by 0. Multiple examples you can write it. Suppose if you don't know what the error type, if you don't know the error type, okay, just use exception. Except just exception. Okay, if you don't know the error, okay, if you don't know the error, just use exception as e. Simple. Same thing. Print. If you don't know the type of error, what type of error, you have to write except exception as e. That's it, simple. If you don't know which type error it is, just write except error. Just take out this one. Just check the output now. See division by 0. Okay, because Python interpreter automatically detects and it results in error. Okay, because it goes to exception here. Okay, so this way you can handle multiple exceptions, and also if you don't know type of error, you can raise this exception. Okay, exception class exception. There are so many errors are there. Type error, 0 division error. If you check this, so type error, 0 division error, value error, file not found error, 0 division error, and others. Okay, so this way you can use try and except blocks to handle the exceptions. And there is also finally block is there. So we'll see with an example. We'll copy this code and print it simple. Okay, or else I hope you understand this simple one. Okay, nothing is there, just finally block is there. So here finally block is there. The final block is nothing but the block will be executed regardless of whether an exception occur or not. Means whether error rises or not, finally block will be executed. Okay, generally close methods will put in this finally block. Okay, close methods are the file dot close methods, and if you want if you want to enter whatever information, you can write in finally block. Okay, so try except block again. This suppose if file is not there, just execute the output. This file not found error, another type of error. So exception means if you don't know type of error, you can try this exception here. Okay, you can write exception here. Okay, simple. Else part file read successfully. So just check the output here. See the specified file was not found. Suppose if your file was found, it returns a file here. Okay, suppose new.txt is there. New.txt in read mode. Just check the output. file it successfully. Okay, the simple one, this one. Or if you want to print the file in the terminal, just here this block you can write here content here. Okay, content, this content, check the output here. See, okay, there's a file content here. So this way you can use a finally block. Okay, I hope you understand try block, except block, else block, finally block. Okay, you can raise your own exceptions also. You can raise your own exception, not a custom exceptions also. So means just use simple. Suppose if a is greater than suppose see if we'll define some function here now. Definition, validate. Okay, age here. So you can take age here as a parameter. If check the condition, if age less than 0, if condition, just print it. Okay, print raise error here. Just say raise your own error, raise value error, whatever error you can raise it here, value error or exception, whatever. Just write method here, value error. Just write some information here. Age should be greater than 0. Age should be greater than 0. Means you can write your own message here. Okay, so suppose call this message now. If so validate, just call -5 here, fine here, just observe here, output here. See, it raises error here. Okay, value error is given, so we have to handle this error here. So you put this in try block and write except block. If you are writing try statement, means compulsory except block has to be written, otherwise it raises error. Okay, except block, in except block you have raised value error. Okay, value error as E, print F E. Okay, just check the output now. Simple. See, it should be greater than 0. Okay, so this is you can raise your own exceptions based on some conditions here. Okay, so that's about the simple errors, raising an exception here, and exception chaining, handleable multiple exceptions we have seen now. So raising exception. Okay, developers can also manually raise exception using the raise statement here. This is useful when a specific condition is met and the program cannot proceed. So here if condition and raise some whatever error. Okay, value error, type error, or exception. Okay, so like that. And exception chaining is there. Exception chaining in Python is a mechanism where one exception is raised as a direct consequence of another exception. So this we'll see in advanced Python. Yes, exception chaining. We have to raise exception as a direct consequence of another exception. Okay, this is achieved using from keyword when using the second exception. Okay, it allows you to provide additional context from the cause of the exception. So we'll see that in advanced Python, and this is so this finishes complete basic Python. Okay, so if you like it, just comment it to for advanced Python. Okay, for advanced Python part of our video. So this 90 minutes for the complete basic Python tutorial. So description available, this document available in the description, and also the tutorials of my Udemy tutorials, also links are available for complete Python exceptions and find exercise are there, interview questions, project, and also web designing also there. So you can check there if you like it. And so installing Python is also there, I will put in description, just check it down. And also Visual Studio setup also link up will I will given. Okay, so that's it.